Okay, so I want to talk about non-orientable surfaces. And non-orientable surfaces begin from these knots. And if you look at the knots, they have different numbers of crossing points. So this one has one, this one has three, this one has four, this one has two, and then they have different regions as well. So I have a separate video. This one has two regions, four regions. They have different numbers of regions and crossing points. And I have a separate video on how to make all sorts of different kinds of knots. In this one, I want to talk about specifically just the simpler ones. Um, and the most important thing is to pay attention to the crossing points. Okay. So the non-orientable surfaces is when the topology of the knot is connected in such a way that the back of the surface becomes the front and the normal switch. You can also connect these knots in a different way, which is called a spanning surface. You can connect knots and links. Links are when you have two curves that interlock, so they can't be pulled apart. You can connect the knots in a way that they are orientable, and that's called a spanning surface or a ciphered surface. But I first want to talk about the non-orientable surfaces. Okay, um, so let's look at that. Okay, so essentially, this is the trefoil, and this is the single knot here. And what is interesting is to just mark the first step is just to mark the crossing points. Okay, so those are the most important parts of the curves. That is where we have to make sure that on one side it is at the top, and on the other end of the curve it is at the bottom. And anytime you're drawing a curve, you go under and over at the crossing points. Okay, so what I typically like to do is then mark some of the other points along this curve, and really any of the other points along this curve do not matter. So like all these other points are just helping us to determine how to draw the curve correctly. The only one that really matters is right here. So you can mark as many or as few points as you wish. And what actually matters is the moment of crossing. So typically in the Mobius band, it's horizontal in this area. And so we mark that, but it doesn't really matter even what it would be there. You could draw it anyway. So then I need to go top. I need to follow the direction of the curve down. And I need to use this. There's two kinds of curves here. There's the regular, and then there's, if I click on this little arrow, I get this interpolated curve, which holds itself to the control points more. So I want to use that. So I go top, around, 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 bottom, around, 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 top. And that is the Mobius band. Okay. And then I can split it at the struts and I can loft it like that. Okay. But the thing about this is it doesn't give me a whole lot of control of the middle. I can really do whatever I want in the middle here. And then if I try to extend this surface, however I oriented the parts in the middle would have a lot of impact in terms of how the surface actually ends up extending. So what I typically do is I try to exert a little more control over the middle. And a different way to think about the Mobius band is as a torus knot, which is basically this strut going around and rotating as it goes around the curve a certain number of degrees. So here it's rotated 180 degrees as it went around the curve. So in this moment, it was rotated 90 degrees. And then it kept rotating and rotated back 180 degrees. So it's a single 180 degree turn as it travels along this. And I could turn it, more or less degrees, and that results in different surfaces. Okay, so in order to build something like that, what I will typically do is instead of looking at the knot this way, I'll simply look at the middle line. Uh, Circles. And then what I'm usually interested in actually is that one in between. because what I like to do is to try to constrain I usually find it easy if I start from a consistent length in these. And then I can just divide this into a certain number of points. So let's do 4. And then I can go, I can copy this band around to each of those, and I can rotate it. And I need to be rotating it um, around a tangent to the curve. So since I only did 4 times, that's easy, but I would want to be rotating it around the orientation of the curve, or it's not going to really have the same idea as the previous one that I showed you. So really, those are the axes of rotation. So I need to be rotating these curves that way. And that allows me control over how quickly or slowly the surface is twisting as it goes around. So if I rotate this 45, I rotate this 90, and I rotate this 45, by negative 45, like that. And then I can go around and draw using my interp curve. I can draw the inner profile, outer profile, connected like that. And then if I split this, and I loft these, those, and loft those, and loft those. Then as I extend this, extend surface the command. As I extend this, it's going to be extending more controlled because I controlled the orientations of the different parts. So let me try to extend this in a more normal way and put it on a more legible layer. Hide these axes. Okay, let's extend this. Let's do 100. Okay. And the reason this is more controlled is very simple. It's just because I made that angle 45 degrees. So what I could do is I could have made it something different. I could have made this angle um, let me make it 60 degrees or 30 degrees. Okay, and this is just forcing how quickly it's turning in any given part. That's all it's doing. Okay. And once I have this, you'll notice that when I extend it, it loses its tangency. Um, and so in order to fix that, what I need to do is rebuild these surfaces. As I need to rebuild them probably one at a time. As degree, you can see in one direction it's degree 1, in the other direction it's degree 3. It says many points. This has 4 points, 4 points, degree 3, degree 3. I want to build this degree 3 with something reasonable, like 10 points. And then if I match surf, I can pick tangency for both of them and average the surfaces. And I can go around and I can match these surfaces to one another like that. Actually, before I do that, I need to make sure they're the right length. So you can see they're sort of missing each other. So I have to extract an isocurve and make sure these things all line up all around the edges. Okay. Then I should, once they line up everywhere, then I should shrink them. Or if I untrim this, it'll return to its original. If I shrink it and untrim it, it's not going to do that. So I want to shrink all of these. I want to rebuild them. And then I'm going to go match surface, tangency, average surfaces. And that will restore the continuity. Okay. And there is a single Mobius band that turned um 180 degrees at once. Okay, so I can do that in other ways too. I can turn it a different number of degrees. So if I want to turn it a different number of degrees, I'm going to do something like this um, instead of turning it um, once as it goes around, I'm going to turn it twice. So first I divided the circle into four, and then I copied the vertical line. And now I need to draw the tangent. And now instead of being down 90 degrees here, I'm going to make it down 90 degrees here. Like that. Okay. And then I need to divide the middle. I think these are too long, by the way. They're going to cause me issues. So I'm going to shorten these. Let me try something better. They need to be the same length. Okay. There we go. Now I'm going to divide this into four parts. Uh, three parts. Let's do four parts. Um, like that. And then I'm going to do uh, copy this there, and there. And then I'm going to do a line tangent from first point, line tangent from first point, line tangent from first point, like that. Okay, and so this needs to be rotated 45 degrees. And then this one needs to be rotated half of that. And this one needs to be rotated three halves of that. Like that. Okay. And then what I can do is I can draw this surface like that, and I can loft these together. Okay, and then I should be able to just rotate this 180 degrees, rotate it 180 degrees. Oops, and then I can mirror it, and then I can also mirror it again. It will go around again like that. Okay, so that's now, I just made 1/4 and then I mirrored it around until it went around all the way. Okay, so now if I put this on a sort of reasonable looking layer and I hide the rest of the curves here, if we extend this, the 50, 50, 50, 50, 50. Yes, we get this um, uh, construction where they go around twice. Okay, so then I'm going to match surface. Oh, I should need to rebuild these. Now I can match surface. Like that. And you can see they almost become the same surface in the middle here. And so what I might want to do is make sure I find the correct axis, dividing this in two, and then make a vertical plane here. And those are basically meeting up, not quite, but in the panelization or the developable strip version, you could make them meet up perfectly. Okay, so there's another type. And then in order to do it with more twists, do the trefoil knot. Okay, so on the trefoil knot, first I just mark the crossings, and then I need some other points that'll be my guides, and those can be anywhere. And I now just go start at the top, go to the middle, and I always go to the underside of the crossing when I was just on the over. So here I'm at the bottom, middle, top, middle, top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, middle, top. Okay, and then I can just split this, create lofts there, and then put these on a reasonable layer, and then rebuild that stuff. Okay, there you go. Now, the important thing to remember about these, you can scale them. And also, they don't need to have this symmetrical shape. So you can build them out of any curved profile as long as they have the same number of crossings. So let me just show you how that might work. If I had this basic trefoil knot here, Doesn't have to have this shape. It can have any shape. And the same is true with the Mobius band. It could have a elliptical shape or something like that. It would work the same way. So uh, I'm just going to draw a more circular one. So I'm just replacing some of these with true. But for this last lobe, what I want to show you is I'm going to just extend this curve straight, extend it straight, and then I'm going to draw my own curve, tangent, by making sure that two of the points lie along those lines. Okay, so then I can delete this original and I have this very um, asymmetrical, different shaped trefoil. Okay, so then I'm going to mark these points, struts, and then I just need some points along here that I can use. So I'm going to do 3 points along each one. And then the thing is, I want to make sure that I'm going to copy the strut. I'm going to divide it into three. Place it at all these points. And that's just a guide for myself. I can draw the curve smoothly. So I'm going to use this curve here, and then I'm going to start top and go down gradually. 1, 2, 3, bottom. 1. Those look like they're divided into 4, so that's wrong. Divide 3. Not okay, so let me copy those around again. 1, 2, 3. 1, 2, 3. All right, so here we go from top, 1/3 down, 2/3 down, bottom, 1/3 up, 2/3 up, top, 1/3 down, 2/3 down, bottom, up, 2/3 up, top, 1/3 down, 2/3 down, bottom, 2/3 up, top. Okay. And then I can split this with the struts. Loft 10. Let's end this. Okay, then rebuild these, shrink them, rebuild, match stuff. Now you have a very differently shaped one. Okay. I think for our purposes, the more simple single or two loop is probably more successful than the trefoils, but I show you that because I think it's more illustrative of how the process works. Now, in addition to that, there's also a scripted version of this, which you can use, which is called Fancy Loft. And that takes a curve that's the directrix, which is the thing that it is traveling around, and then it takes the generatrix, which is the profile. I put that set one curve, and then this is the extension, and then this is the rotation. So let me make that something smaller so we can see it. This is the rotating one. This is now rotating two, three, etc. So if I do two and I extend this, it's producing this surface, you can see. And if I do one, it's producing the first surface. And that is a very smooth way of doing it because it's doing it in many, 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 many steps. And you can also very easily distort this, and make this shorter so you can see what's happening. Okay, you can see it's not quite working, and that is because the generatrix and the directrix are not aligned. And if you select this curve and you go curve start, it will mark the start of the curve, and then you can put the generatrix there, and then it will work. So you can theoretically make this any sort of weird shape. That weird of a shape. The directrix is on the starting point, it will close that. Okay, so then I can extend these, and I can make the same surface with a different shape. Okay, so that is how that works. And if I do that, um, I can get these surfaces maybe a little bit easier or maybe harder, depending on your point of view.